Hello students, right here again. Today we're looking at practice problems 10.3. You should have already completed these. Now we will look at the solutions and do any corrections you need to make sure you know how to do these problems. In this little part we're going to be changing between mass and moles of compounds. And we'll also look at calculating the average atomic mass of a compound. So here we've got 17.2 grams of benzene, and we want to change that to moles. So first thing we have to do is find the average atomic mass of benzene. So it's made up of carbon and hydrogen. Looking at a periodic table, we find the molar mass of carbon is 12.011 grams per mole. And the average atomic mass of hydrogen is 1.0079 grams. The formula says there's 6 carbons, so we're going to multiply it by 6, and it says there's 6 hydrogens. And we do a little multiplying. 72.066, 6.047, 4. Then we're going to add those together. We'll cut it off right here so that 4 doesn't matter. Typically 2 or 3 decimal places is good on an average atomic mass. And that gives us 78.113 grams per mole of benzene. Then it's just like doing it for an element. We just take the mass, 17.2 grams of C6H6 times 1 mole of C6H6 is 78.113 grams of C6H6. Grams divide up grams. And after we divide that out, and looks like we get to keep 3 sig figs. So that would be 0.220 moles of the benzene, C6H6. Number 17, got 350.0 grams of the potassium chlorate, and again we're going to moles. So first, finding our average atomic mass, we've got potassium, chlorine, oxygen. Potassium, from the periodic table, we find its molar mass is 39.098. Chlorine is 35.453. Oxygen 15.999 times 3 oxygens, 1 chlorine, 1 potassium. We're multiplying 39.098, 35.453, and 47.997. Add all that up, we get 122.548 grams per mole. And we do our little conversion. We had 350.0 grams of the potassium chlorate. And 1 mole of it is 122.548 grams of the potassium chlorate. Stick that up here too. Grams cancel grams. Little bit of division here. This time we got to keep 4 sig figs with 350.0. That would be 4. So 2.856 moles of the potassium chlorate in at 350 grams. This time we're got some tin sulfate. And we got moles, and we want to go to grams. That's determine the mass. So again, we're going to find the molar mass. Sn, S, and O. Periodic table tells us tin is 118.69, sulfur is 32.06, and oxygen is 15.999. 4 oxygens and 1 of each of the others. Multiply. And then we add all that up and you get 214.746. I'll just round that to 214.75, as 2 of them only had 2 decimal places. Grams. Oops. Grams per mole. Hit the wrong little button there. Jump head aside. Back. Now we get to change to 0.187 moles of the tin sulfate. So I put the mole on the bottom this time. And we just figured out that was 214.75 grams of tin sulfate and 1 mole of tin sulfate. Multiply those numbers, moles divide out. And we're left with, and looks like we get 3 sig figs, 40.2 grams of tin sulfate in the 0.187 moles. I'm doing 19. This time we've got 1.35 moles of the ammonium dichromate, and we want to know the mass, or grams. So we've got some nitrogen, hydrogen, finding its molar mass, some chromium, and some oxygen. Nitrogen from periodic table, we find 14.007. Hydrogen 1.0079. Chromium 51.996. Oxygen 15.999. Yeah, there's 2 nitrogens because we got the N and then in parentheses 2. There's 8 hydrogen because there's a 4 and then a 2. 2 chromiums and 7 oxygens. This one I'm not going to write everything out. If the only thing you need is the molar mass, we will be looking at some problems later where you're going to need each of these individual multiplications to do what we call percent by mass. But if you just need a molar mass, you don't have to write everything out. And I'm just going to multiply, 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 and add and do it all in one step on the calculator. And I find we got 252.06 grams per mole. And we do our conversion. 1.35 moles of the ammonium dichromate. And there in 1 mole we have 252.06 grams. And I'm going to not write this time because I don't have enough room the symbols out at the end, but the moles is going to cancel the moles. And we multiply, and we need 3 sig figs, and 3 is 340 grams, but that's really only 2 sig figs because that 0 is not considered significant. So to make it look actually be 3 sig figs, we're going to switch it to scientific notation. 3.40 times 10 to the second grams of the ammonium dichromate. And it says what mass of each here. So we got 2 things, mass of each. So we got 0.200 moles of zinc metal and then copper 2 nitrate. So we'll take care of the zinc metal first. That'll be a nice simple one like we did previous lesson. We just take the 0.200 0.200 moles of zinc, and from a periodic table we find zinc has a molar mass of 65.38 grams of zinc in 1 mole of zinc. Mole of zinc cancels mole of zinc. Doing a little multiplying, and it looks like we get to keep 3 sig figs. 0.200 is 3 sig figs, 13.1 grams of zinc. So there's our first answer. So student should mass out 13.1 grams of zinc. Then we got to do the copper 2 nitrate. And here we first have to figure out the molar mass. So we've got copper, nitrogen, oxygen. 63.546 for copper. 14.007 for nitrogen. And 15.999 for oxygen. Copper, there's 1. Nitrogen, 2, because I got the parentheses with the 2. And oxygen, the 3 and the 2, multiply those together, we got 6. So 6 oxygens. Again, we'll just multiply and multiply and add. Do it all in one routine on your calculator. And we should got 187.55 grams per mole for the copper nitrate. And we had 0.200 moles of the copper nitrate. And we just figured out it's 187.55 grams. Again, I'm running out of room, so I'm not going to write everything out here. In 1 mole, we'll leave out the symbols, but you should always put these in. Mole cancels the mole worth of grams of copper nitrate, and we do a little multiplying. And I find 37.5 grams, once again 3 sig figs of the copper nitrate. Should be massed out. So that's a little look at finding the molar masses of compounds, and then switching between mass and moles of compounds. So till next time, strike.